Till now we had discussed the series voltage regulator, which is positive input, positive output. But there are many applications where you will need a negative voltage output, negative voltage regulation. So how do we get a negative voltage regulator? So let us start with this positive voltage regulator and modify it to give you the negative voltage regulator. First of all, Vi, which is positive here and negative here, we will reverse that. So we want plus and minus like this. Now this should finally result in an output with plus and minus here. So this will give you a negative output. However, the current flow is in this fashion. Therefore, we have to reverse the transistors. So to keep the circuit same, what I will do is convert these transistors from NPN to PNP. So you will see a reversal in the current flow without affecting the topology of the circuit. I will change this from NPN to PNP, still maintains the same topology. So I should also reverse the Zener diode direction in this fashion. Now you have your negative voltage regulator. I will remove that, and these current directions will reverse. So you will have the base current flowing this way and the collector current flowing this way and IB flowing in this fashion. Still the same concept holds. This potential and this potential are fixed and the current through RB is more or less constant, and these two sum up, add up to make IRB. And this is the direction of I naught. So the operation is exactly same as we discussed for the positive voltage regulator. Now this is a negative voltage regulator where I can give a negative input and get a negative output. If you combine the positive voltage regulator and the negative voltage regulator, you will get the dual power supply. Let us just integrate that these two circuits and see how a dual voltage power supply looks like. Let us now see how we get the dual power supply. First, let me insert here the positive voltage regulator. So you have this as the ground line, and this is positive with respect to the ground line, and the output voltage also, this node is positive with respect to the ground line. All are NPN transistors. This is the positive voltage regulator. So giving a positive input, I get a positive output here. Now let me place here the negative voltage regulator. So we just now discussed the negative voltage regulator, the negative voltage here, and I've replaced all the NPNs by PNP. Compare with this. Now I will use this as the common ground point. So that as the ground, place that ground there. Now I will common these two ground points, which means that I will have to flip the circuit such that this ground comes in there. So let me redraw the flipped negative regulator. So let me redraw that. So I am redrawing with the ground flipped. Compare. Now this is a PNP. I'm replacing the NPN with the PNP. I'm replacing this NPN with the PNP. But now the regulator is flipped. Compare with what we have drawn previously. This is R0. These are the output terminals, and I am having an attenuation and taking the attenuation point here. I need to have the bias resistance for this transistor, and I have to give the series resistance for the Zener. So this becomes our dual power supply regulator, common ground. So for example, let us say I give 15 volts for this positive regulators, 15 volts plus and minus, and for this also 15 volts plus and minus like this. But this is the ground point. I will pull it out. Let's say that is 0. So with respect to this ground, this node is positive, so plus 15. With respect to this ground, this node is negative 15, so it is minus 15. So we have 15, 0, minus 15 at the input, and at the output, this is again ground. Okay, this is the measurement direction. Now let us measure like this with respect to the ground, always with respect to the ground. So you are measuring this node potential with respect to the ground, that is this node potential with respect to the ground, that is this. So let us say a 10 volt supply we want at the output with an input output differential of 5 volts in each of the regulators. So at this point, let us say we have 10 volts plus 10 volts with respect to this ground. This is 0. And with respect to that same ground, if I measure here, I will get minus 10 volts. So this gives me a plus 10, 0, minus 10 volt dual output power supply. So this 10 volts plus 10 minus 10 volts is regulated, plus 15 minus 15 is the input unregulated. So this is the integrated schematic of a dual power supply linear regulator, both positive and negative together.